Why study the history of technology? We are connected to our ancestors in ways we rarely see. Every tool we use is part of a very long story that started with a simple idea: making life easier. That impulse has carried us from caves to cities. Each object around us has a history, built over thousands of years. If we pull on one of these invisible threads, we can trace it back to a moment of discovery. It is a human story of curiosity, creativity, and collaboration. By looking back, we can better understand the forces that are shaping our world today. Our story begins in a time we can barely imagine. Picture early humans, living in a world full of dangers and challenges. They had no supermarkets, no houses, no modern comforts. Their survival depended on their wits and their ability to work together. It was in this environment that the very first technology was born. It was not a complex machine, it was a simple stone, carefully shaped to have a sharp edge. This tool, a hand axe, might seem primitive to us now, but for our ancestors, it was a revolutionary invention. It was the key that unlocked a new way of life and set us on an incredible path. With this simple tool, early humans could do things they could never do before. They could cut meat, scrape hides, and shape wood. It was a multi-purpose gadget that extended the power of their hands. This was more than just a convenience. It was a fundamental shift in our relationship with the world. For the first time, we were not just living in nature. We were actively shaping it to meet our needs. This act of creation, of making a tool to solve a problem, is the foundation of all technology. Every single invention that followed, from the wheel to the rocket ship, shares a common ancestor in that first sharpened stone. This journey from the first stone tool to the smartphone in your pocket is a long and winding one. It is a story of incredible leaps and surprising connections. The path is not a straight line, it is a web of ideas, where one innovation creates the possibility for another, often in unexpected ways. The discovery of fire allowed us to cook food, which may have helped our brains develop. The invention of writing allowed us to store and share knowledge across generations, creating a collective memory for our species. Each step, no matter how small it seemed at the time, built upon the last, creating a ladder of progress. This essay will take you on a deep dive through that magnificent history. We will explore the major turning points and the key inventions that changed everything. We will move through time, from the ancient world to the digital age, to see how these changes unfolded. We will meet the inventors, the thinkers, and the ordinary people whose lives were transformed by new technologies. Our goal is to connect the dots, to show how a simple tool for survival evolved into the complex, interconnected world we inhabit today. It is a story of how we got from there to here. To make sense of this grand story, we will divide it into several key periods. Each era is defined by a set of transformative technologies that reshaped society. We will begin our journey in ancient times with the very foundations of human civilization. This is the age of fire, the wheel, and the first agricultural tools. These were not just inventions, they were the building blocks of settled life. They allowed humans to move from small nomadic groups to larger communities, villages, and eventually the first cities. This period shows us how basic tools can lead to profound social change, setting the stage for everything to come. Next, we will travel forward to the classical world and the Middle Ages. This was a time of incredible intellectual and practical breakthroughs. We will see the birth of writing and mathematics, which allowed for complex record-keeping, law, and literature. Great civilizations in Greece, Rome, China, and the Islamic world gave us massive architectural wonders, sophisticated metalworking, and crucial inventions like paper and the compass. These innovations did more than just make life easier. They expanded the human mind and connected the world in new ways, spreading ideas and goods across vast distances like never before. It was an age of foundational knowledge. Our timeline will then accelerate as we enter the age of discovery and the Industrial Revolution. This is where the pace of change really begins to pick up. The invention of the printing press democratized knowledge, fueling the scientific revolution and the Enlightenment. Then came the steam engine, a machine that would literally power a new world. Factories rose, cities grew, and the telegraph and telephone began to shrink the globe. This period fundamentally altered how people lived, worked, and communicated, creating the modern industrial society that we would recognize today. It was a time of smoke, steel, and speed. Finally, we will arrive in our own time, the digital era. This is the age of the computer, the internet, and the mobile phone. These technologies have connected humanity in a global network, transforming every aspect of our lives, from how we work to how we socialize. Information that was once scarce is now abundant, available at our fingertips. We are living through a period of change that is faster and more far-reaching than any that has come before. By exploring this entire timeline from stone to silicon, we can fully grasp how technology has not just changed the world, but has actively created the world we live in today. Long before cities, humans discovered fire, forever changing our species. At first a destructive force, our ancestors learned to tame it. Mastering fire brought light, protection, and warmth, revolutionizing diet by making food easier to digest. This fueled brain development, paving the way for technology. Fire was humanity's first step in reshaping the world. While fire transformed our lives, another revolution was taking place: the Stone Age. Shaping rock into tools was a massive cognitive leap. Early Oldowan tools were simple but effective, allowing ancestors to butcher animals and process plants. Over time, tools became more sophisticated, like the Acheulean hand axe, requiring skill to create. The Levallois technique improved efficiency, creating sharp flakes for knives. This expanding toolkit improved survival, enabling humans to thrive in diverse climates. The Stone Age laid the groundwork, teaching us that tools overcome limitations. For most of human history, we were wanderers. We lived as hunter-gatherers, moving from place to place in search of food, but around 10,000 BC, something extraordinary began to happen in different parts of the world. Humans started to cultivate plants and domesticate animals. This was the agricultural revolution, a change so profound that it completely rewrote the rules of human existence. This shift was not born from a single invention, but from a new suite of technologies designed for a new way of life. It was a transition from finding food to producing it, and it would pave the way for civilization itself. The first tools of agriculture were simple but effective. Humans used sharpened digging sticks to plant seeds and stone sickles to harvest grains. A sickle was a curved blade, often made by setting sharp flint pieces into a wooden or bone handle. It allowed a farmer to cut down large amounts of wheat or barley far more quickly than by hand. Another key invention was the grinding stone, or quern. This tool, consisting of two stones rubbed together, was used to grind the hard grains into flour. This unlocked the full nutritional potential of the crops and made them a reliable, storable food source that could sustain a community through the lean months of winter. These new tools did more than just create food. They created a new relationship with the land. For the first time, people began to stay in one place. This led to the creation of permanent settlements, the first villages. Life became organized around the seasons of planting and harvesting. To manage these new tasks, other technologies were developed. Pottery was invented to store grain and water, protecting them from pests and moisture. Weaving, using simple looms, allowed people to turn plant fibers like flax and animal wool into textiles for clothing and blankets. Life was becoming more stable, more predictable, and more complex. This revolution also brought new challenges that demanded new technological solutions. Farming in one place for years would deplete the soil of its nutrients. This led to the invention of the plow. Early plows were simple, human-powered wooden frames that scratched a furrow in the earth, but they were a huge improvement over digging sticks, allowing farmers to turn over the soil and bring fresh nutrients to the surface. Later, the plow was adapted to be pulled by domesticated animals like oxen. This was a monumental step, leveraging animal power to do work humans could not. It dramatically increased food production, creating surpluses that would fuel the growth of the first cities. As agricultural surpluses grew, villages began to expand. They became larger, more populated, and more organized. This was the dawn of urbanization, the birth of the city. But to build and sustain a city, you need to be able to move heavy things. You need to transport food from the fields to the city center, and you need to move building materials like stone and timber. For this, a truly transformative invention was needed. And around 3500 BC in Mesopotamia, it arrived: the wheel. Interestingly, the first use of the wheel was not for transport but for pottery. The potter's wheel allowed for the fast and uniform creation of ceramic vessels. It did not take long for people to realize that a wheel turned on its side could be used for movement. The first wheeled vehicles were simple, solid wooden carts pulled by oxen. They were slow and clumsy, but they were revolutionary. A cart could transport a load that would take many people to carry, and do it over a much longer distance. This was a force multiplier for human labor. It made it possible to build on a grander scale than ever before. Massive stones for temples and palaces could be moved, Large quantities of grain could be brought to central storehouses. The wheel was the engine that powered the construction and supply of the first urban centers. The invention of the wheel had a ripple effect, spurring other technological developments. To make wheeled carts effective, you needed better surfaces to roll them on. This led to the construction of the first roads, engineered pathways designed to make transport smoother and faster. The wheel also required more advanced woodworking skills to create the axles and frames. And it led to a new profession, the wheelwright, a specialized craftsman dedicated to this crucial technology. The wheel connected the new cities to the surrounding countryside, creating a network of trade and communication that was essential for their survival and growth. The rise of cities, powered by agriculture and the wheel, created a new kind of society. With food surpluses, not everyone had to be a farmer. This allowed for the specialization of labor. People could become priests, soldiers, merchants, and artisans. This concentration of people and skills in one place created an environment ripe for further innovation. Cities became centers of knowledge, culture, and power. It was in these bustling urban landscapes that the next wave of world-changing technologies, such as writing and metallurgy, would emerge. The ancient beginnings, starting with fire and stone, had successfully laid the foundation for civilization. As cities grew, a new problem emerged. How do you keep track of everything? The solution was writing, beginning around 3500 BC in Mesopotamia with cuneiform. Scribes pressed wedge-shaped marks into clay tablets, a technology for accounting. Knowledge could now be stored reliably outside a single human mind. Later, Egyptians developed hieroglyphs and papyrus, making information more portable. The alphabet, pioneered by the Phoenicians, was a masterstroke of simplicity. The alphabet democratized literacy, spreading ideas faster and further. This was the software that would run civilization. While writing reorganized the mind, metallurgy transformed the physical world. Around 3300 BC, copper was discovered. Mixing it with tin created bronze, a monumental leap forward, leading to superior tools and weapons. The Bronze Age was a period of intense conflict. Creating bronze required specialized knowledge. Workshops became the earliest factories. Bronze was replaced by iron around 1200 BC. Iron was cheaper and more accessible, democratizing metal and laying the foundation for great empires. The civilizations of ancient Greece and Rome built upon writing and metallurgy to create wonders of engineering that still inspire awe today. The Greeks were thinkers and theorists, giving us the foundations of geometry, physics, and philosophy. They invented the screw and the crane. The Greeks designed incredible structures like the Parthenon. The Romans scaled Greek ideas to an unprecedented level. They perfected the use of the arch, the vault, and the dome. But their most important material innovation was concrete. They built over 80,000 kilometers of paved roads. They built monumental aqueducts. In the cities, they constructed enormous amphitheaters like the Colosseum. Roman engineering was a technology of power and control. While Greece and Rome shaped the West, civilizations in the East were also innovating. Ancient China invented paper, revolutionizing knowledge accessibility. They also developed advanced metallurgy, including the blast furnace. Chinese alchemists discovered gunpowder, initially for fireworks, later for military use. During Europe's stagnation, the Islamic world preserved and expanded Greek and Roman knowledge. They advanced mathematics, developing algebra and the Hindu-Arabic numeral system. Islamic engineers designed complex automata, and their medical facilities were ahead of Europe. They also perfected the astrolabe for navigation and timekeeping. These innovations fueled future advancements in human history. For centuries, knowledge was rare. Books were copied by hand, slowly, mostly by monks. A single book could take years to produce, making it expensive and accessible only to elites and the clergy. This scarcity slowed progress. New ideas were contained, slowing their spread. Brilliant minds worked in isolation, unaware of discoveries elsewhere. A new technology was needed to break down these walls. That technology arrived around 1440 in Mainz. Johannes Gutenberg developed movable type printing. He combined existing technologies into a highly effective system. This process could be repeated thousands of times a day. The impact was immediate and profound. The first major book printed was the Bible, suddenly widely available. The cost of books plummeted, and literacy rates climbed. A flood of information was released across Europe. This explosion of ideas fueled an era of change. It empowered individuals and laid the groundwork for the scientific revolution and the Enlightenment. The printing press helped share ideas, but new tools were needed to push the boundaries of knowledge. The scientific revolution was a revolution in instrumentation. New tools extended the human senses, allowing us to perceive realms that were previously invisible. The telescope revealed mountains on the moon and moons orbiting Jupiter. The microscope opened up another unseen universe, revealing bacteria and red blood cells. The universe was not only larger than we imagined, but also infinitely more detailed and complex. These instruments allowed for precise measurement and observation, turning natural philosophy into a true empirical science. The scientific revolution revealed the principles of pressure, vacuums, and heat. The next leap was using this understanding to create machines that could do work. For centuries, power came from muscle, wind, and water. But in the 17th and 18th centuries, inventors experimented with steam. Early engines like Savory's were inefficient and prone to explosion. Newcomen developed a safer, more effective engine. James Watt improved the steam engine by adding a separate condenser, dramatically improving efficiency. Watt's engine became a universal power source. The steam engine unlocked the Industrial Revolution, powering factories and transforming the world. The new technologies of print, scientific instruments, and those early engines did more than just change what people could do. They changed how people thought. This period, known as the Enlightenment, was an intellectual movement that championed reason, individualism, and a healthy skepticism of traditional authority. Thinkers like John Locke, Voltaire, and Adam Smith argued that the universe and human society could be understood and improved through rational inquiry, not just through faith or tradition. This was basically the scientific method spilling over into politics, economics, and human rights. Technology wasn't just a tool, it became a model for thinking about progress itself. The printing press was the essential engine of this intellectual movement. It allowed Enlightenment ideas to circulate rapidly and widely through books, essays, and pamphlets. Coffee houses in London, salons in Paris, and universities all across Europe became buzzing hubs of debate and discussion, all fueled by the constant flow of new printed material. For the first time, a large, literate public could really engage with the big questions of the day. This created what people called a republic of letters, an international community of thinkers who corresponded and debated, building a collective intellectual project to reform society based on evidence and logic. This belief in progress and reason fueled a drive to organize and spread all human knowledge. The ultimate expression of this ambition was the French Encyclopédie, a massive multi-volume work edited by Denis Diderot and Jean-Laurent d'Alembert. Its goal was to gather all knowledge of science, arts, and crafts and present it in a rational and accessible format. The Encyclopédie was more than just a reference book, it was a political statement. It celebrated technology and skilled trades with detailed illustrations of everything from windmills to pin-making factories. It promoted a worldview where human ingenuity and labor were seen as the true sources of wealth and progress. This era laid the philosophical and practical foundations for the modern world. The belief that problems could be solved through rational analysis and technological innovation became deeply embedded in Western culture. It fueled not only the Industrial Revolution but also the political revolutions in America and France, which aimed to build governments based on rational principles and individual rights. The age of discovery and progress, which began with the simple act of arranging metal letters, had really culminated in a new worldview. A world where humanity felt empowered to understand, to invent, and to consciously direct its own destiny toward a better future. The steam engine, perfected by James Watt, transformed industry from small, scattered workshops to massive, centralized factories. No longer tied to rivers, factories could be built anywhere coal was available, fueling the explosive growth of industrial cities. Entrepreneurs filled these new buildings with machines powered by steam, revolutionizing textile production and slashing the cost of goods. Ordinary people could now afford items once considered luxuries. The factory system drew people from rural areas into cities where life was dictated by the relentless pace of machines. Work became repetitive and specialized, increasing efficiency but often at the cost of worker safety and well-being. The demand for machines, fuel, and transportation spurred further innovation in iron, coal, and railways. The factory became the engine of a new economy, one built on mass production and unending growth. As steam powered the world, a new force, electricity, emerged from the lab to transform daily life. Thomas Edison's incandescent light bulb, and the electrical system he built around it, brought safe, clean light to homes and cities. Electric light extended work and leisure into the night, making cities safer and more vibrant. Electricity soon powered motors, freeing factories from the constraints of steam engines and making production more flexible and efficient. Every machine could now have its own motor, reshaping factory layouts and improving safety. The simple act of flipping a switch became a symbol of modernity. Electricity wasn't just replacing steam, it was creating a new, dynamic industrial landscape. The world was now truly lit by wire. The Industrial Revolution didn't just change how things were made, it changed how people connected. The telegraph, pioneered by Samuel Morse, sent messages at lightning speed, shrinking continents and oceans. The transatlantic cable linked Europe and America, making global news and business instantaneous. Alexander Graham Bell's telephone brought real-time conversation into homes and offices, revolutionizing personal and business communication. These inventions, alongside railways and steamships, made the world feel smaller and more connected. Business, politics, and relationships all accelerated. The annihilation of space and time became the nervous system of the modern world. The stage was set for an even more interconnected future. The dream of a machine that could think began with room-sized electronic computers built during World War II. These early giants, like ENIAC, were powerful but unwieldy, reserved for governments and research. The invention of the transistor and integrated circuit shrank computers from rooms to desktops. Mainframes revolutionized business and science, but the real leap came with the microprocessor. Suddenly, computers were small and affordable enough for personal use. The personal computer put information processing power in the hands of individuals. What began as a tool for corporations became a household necessity. The thinking machine had arrived. The personal computer was powerful but isolated until networks changed everything. ARPANET, a military project, laid the groundwork for a resilient, decentralized network. Tim Berners-Lee's World Wide Web made the internet accessible, linking documents and people with a click. The internet exploded in the 1990s, connecting homes and creating a global digital commons. Email, online shopping, and instant information became everyday realities. The world was woven together in ways never before imagined. Physical distance faded as the internet created a true global village. The digital age had arrived, transforming how we live, work, and connect. The digital revolution put a computer on every desk and connected them. The most recent phase placed the entire global network into our pockets. This was the mobile revolution. The watershed moment came in 2007 with the first iPhone. It combined a powerful computer and seamless internet connection. It was a telephone, an iPod, and an internet communicator all in one. The smartphone transformed our relationship with technology. The internet was always with you. It has changed how we work, shop, bank, and even date. The mobile phone has become our primary portal to the digital world. It is the most personal computer ever created. Our journey through time is now complete. We have traveled from the dawn of humanity to the cusp of tomorrow, tracing the story of technology. We started with our earliest ancestors, who first chipped a stone, an act that set us on a remarkable path. Each step built upon the one before it, creating an unbroken chain of innovation. Now we live in the digital era, woven together by the internet. The tools have changed, but the human impulse to create remains. What does the future hold? The chain of innovation continues to accelerate. It is now our turn to forge the next link in the endless chain of human progress.